Here we are at the end. I'd like to take about 20 or 25 minutes to hopefully impart some wisdom. As you've watched through these videos and with any luck learned something, there's a lot of things that I've gone through and only glanced at. And it's important from this point out that you take the ideas that I've introduced and expand on them yourself. There's so many different ways to do things, and they're all correct. Some are maybe more correct than others, but if you get the job done, it's not wrong. I have a lot of friends that are in this business, and I've talked to them for the long amount of time that it's taken to do this series. And I've asked them, what do you wish someone had told you? And they all had some interesting answers, and luckily I had covered some of it. Some of the things I haven't covered as thoroughly as I thought, and so here at the end, as kind of a relaxer and a recap, I'm going to show you some commands and some techniques that will hopefully help you out so that you don't have to spend hours and hours searching the internet. The first comment went a little bit like, when I first started out, I had no idea how to monitor processes on the system. I've already covered PS before, but here's a couple of more commands that might be useful. Top, iostat, free, dstat, and a special file called proc_meminfo. Let's examine top first. Top lists the processes that are running, and it sorts them in the order of certain criteria. So by default, it sorts them by the amount of CPU that's in use, or by the amount of memory that's in use. So a couple of things that you can see right off are that we've got the number of total processes running at the top in the header, the load average, what the different processes are doing, CPU idle, information like that. And you'll notice that dynamically, it's sorting the list by the amount of CPU that's used. Just shortly ago, it was MySQL. Now top itself is actually using it now in it. If you're getting a lot of latency on your machine, this is one of the really quick ways to check out and find out why it's happening. And then maybe you need to kill a process, or maybe you need more RAM in the box. You really never know. But luckily with top, you can probably find out. Next up, we want to install two packages that are also relevant to this. The first is sysstat, which contains a utility called iostat, and the other is dstat, which contains a utility called dstat. And dstat and iostat do kind of the same thing, but in different displays. Iostat is going to show you a kind of a real-time snapshot of what your disk I/O looks like. So we can see here that we're really not using much of anything. Dstat is a little bit more informative. It shows you a lot of columns with a lot of information. We see user, sys, and idle. Those are CPU usages. And then as you go across, you can kind of get a feel for what the different things are. Like disk total is an I/O column. The network receive and send are pretty self-explanatory. Paging and then system interrupts and context switches are both CPU kind of statistics that are useful. That spike that just showed up on the network and the disk I/O was me loading a couple pages from Apache. You can induce I/O or induce whatever kind of load you're seeing, and as you run dstat, these numbers are going to jump around. So if you see that your CPU, user space CPU, has suddenly jumped to 100% and stays there, then you know that whatever's beating down the system is using CPU resources, but maybe it's not using disk. So you get a nice combined view of everything that's going on from this screen. The one thing that it doesn't show is free memory, though, which you can get from a different command. Actually, there's a command called free, and that shows you just a general memory usage breakdown. And then there's a file called proc_meminfo that shows you a little bit more information about the same thing. Proc is a specialized file system that has what we call kernel tunables, and all it does is show things that the kernel exports in real time. Proc itself, aside from meminfo, is really interesting. There's a ton of files in there that give you this really low-level view of what's going on in your system. The more you learn about the files in there, the more you can get a feel for what's happening. But meminfo is a good place to start. Number 12, job control. Bash, the shell, lets you handle multiple jobs at the same time from the same window. This is really useful if you have something that's long-running, or you have something that's running and you want to temporarily suspend it just to check out what else is going on in the system. Most running processes can be suspended using Control-Z, and once you've done that, they are backgrounded, and they no longer run, as in if they were processing data or doing disk I/O or anything like that, they will stop. You can then use the BG command to background the most recent process or give it a process ID. and then it'll continue running in the background, and it'll continue dumping text into your terminal also. You can also use FG to bring the command back into the foreground, or you can kill it. And the jobs command shows everything that's running. Example time. A good example of a well-behaved backgroundable process is the MySQL command line interpreter. If I fire up a MySQL connection and check out the databases just to make sure that it is in fact connected, and then I hit Control-Z to background it. So we can see that there's one job running, and I want to add a second job. So in a previous example, I'd use top. We'll fire top backup, and then Control-Z it. Jobs command shows that there are two jobs running, both are stops, which means that they're not producing I/O and they're not reading any disks or anything like that. For that extra bit of confusion, I want to fire up a process that dumps something to screen all the time, so that we can then background it and see that the screen dumping stops. Tail-F on some log file should work fine for that. One last Control-Z is going to drop me out of the tail and leave it suspended. I now have 3 suspended jobs. Using the FG command, which is short for foreground, I'm popping back into the MySQL command line interpreter, ran a MySQL command, backgrounded it again, brought top back up, Control-Z'd it again to put it back into the background. The tail-F isn't showing us any messages. Apparently there's nothing going to varlog messages right now, so I'm going to pick a different file. Control-C killed it, and then you'll notice that it disappeared from the jobs listing. The daemon log typically has a little bit more info. So what I'm going to do is Control-Z this tail, and instead of letting it stay stopped, I'm going to background it. Tail is going to continue running in the background, and if it gets any type of output, it's going to dump it to my console. I FG the MySQL command back in, check to make sure that it's working just to prove it's no trick. And then in the other console that I have open off screen, I'm going to restart bind. Since that tail is running in the background on the log files, when bind restarts, it's going to dump the log file output to my current console. Notice now that the bind log output is mixed in with the MySQL command output. It can get kind of confusing, but you can also do, if you want to watch 50 log files at once, you can tail all of them, background all of the tasks, and then everything will get dumped as one concurrent display. Here's another shortcut. If you list your jobs and want to kill one, you can kill that job ID using a %sign instead of having to find the process ID. In a similar vein to process control, sometimes you want to run a command that's going to take multiple hours or even multiple days, and you don't want to run the risk of having your client PC shut down, disconnecting your session, and then having it kill the process. Any process that isn't backgrounded when you kill the session will stop running. But sometimes backgrounding isn't good enough. Like perhaps you want it to run for a long time and dump to a log file. Or maybe you want to be able to run a process from your terminal, shut down your PC, boot the PC back up, and reconnect to the process. To do that, we can use NoHub and Screen. NoHub is definitely the simpler of the two. What NoHub does is take the command that you give it and run it, and when you disconnect from the console while it's in the background, it will continue running the command and dump the standard output to a file. So what I've got here is this huge ISO that I need to download for an Open Indiana build. And I'm seeing that it's going to take a long time, and I probably want to go home. My computer isn't on a backup battery, and so I don't want my PCs crashing to fail this download in a couple of hours after I've left. So what I can do instead is use NoHub. So one way that I could get around this problem of having the application potentially crash if my terminal disconnects is by adding an ampersand at the end. When you add an ampersand, the command automatically gets backgrounded, just as if you'd hit Control-Z and use the BG command. The problem is that dumps all of the standard output from wget into my console, ruins the entire display. I could redirect output to dev null or to a file. That would be fine too. But the NoHub command already has that built in. It's going to redirect the standard output to nohub.out, which I can then check out at my leisure, and I can see that the wget is making progress. Now if I exit the console, the nohub process will continue running and it will continue dumping to this file. It's a little bit easier than using redirections and maybe a little bit more straightforward. I've switched to a different SSH session here so that I can show that nohub and the process are still running. So if I grep for wget, You can see that it's there, and it's still pulling down the ISO file that I had started earlier. And I can also check out the NoHub file the same as I was on the other screen. So this is useful, but it's not terribly useful. About the only thing I can do at this point is kill the wget. I don't have any control over it. That is easily remedied, though, with a program called Screen. Screen will let you attach and detach to a console session. You SSHN or whatever and run the screen command, and it kind of fires up a new terminal of its own. And then once you're inside of it, you can attach and detach from any location. So I ran Screen by itself, and it looks like I have a blank console. And I want to pull in this ISO file one last time, but instead of just letting it run, I'm going to do a special screen command called a detach using Control A and then D. For your benefit, I'll check that the wget is still running, and then I'll do a screen-ls, which lists the current screen sessions, and then a screen-r, which will reattach to the screen that I just exited from. You'll see that it's pretty much the same display, that the ISO is still downloading. I don't need it anymore, and I can go ahead and exit out of the screen. And when you exit, it'll tell you, and anything that was running inside the screen session is then destroyed. That's one use case for Screen, but it's not the only one, and it's probably not even the most interesting one. The most interesting one is that since you can reattach to a screen that's running inside your SSH session, there's no rule saying that you have to reattach to it from the same SSH session. So you can SSH in your machine from your work PC, start some long-running process, and then detach from it, go home, connect through your VPN or whatever, SSH in again, and then reattach to the same screen session you had left at work. Whatever you had left running had continued to run while you drove or biked home, as if you were there the whole time. So we've abstracted away the console connection itself. Allow me to demonstrate using this incredibly hard-to-read screen capture. I've got two SSH sessions to server 01, and I'm going to try switching between the two using Screen. To really demonstrate this totally neato feature, I need something that constantly updates the screen. In this case, we can go back a couple examples and use dstat again. Once it's up and running and I've got something here, I can detach from this screen, and then I'm going to switch to the other SSH console. Once again, that's a Control A, D. With the -R to reattach, we can see the dstat has no idea what just happened. The curious admin is probably saying, but what happens if I got home and forgot to detach from work? You can actually force Screen to detach your other session by using a -D in combination with -R. You saw the screen switch, but you probably couldn't see the command I typed. In Super Zoom, it looks a lot like screen-D-R. Somebody else mentioned Bash history. Bash maintains a history file, by default 500 lines, of everything that you've run. It's searchable, and you can also check out the plaintext file. The most obvious way to go through your Bash history is with the up and down arrows, which I am so cleverly demonstrating here. If you hit Control R and then start typing, it will try to match any command history entries with whatever it is you're typing. In this case, I was typing bind, B-I-N-D, and the last or most recent history that I got was for a sudo externity bind restart. Once you find the line you're looking for, you can edit it however you want, and it'll save it as a new history line. It won't affect the one that you found before. In addition to text searching, sometimes what you actually want to do is look through your history as a whole. The history command itself will dump your history, and then that gives you something that's easily either moreable or greppable. This is a lot more useful than Control R if you don't quite remember the context around the command, but you remember some type of string that was in it. This way you can see them all at one time and like, oh, right, I wanted to restart bind9. All of this is stored in a file called .bash_history in your home directory, and of course you can edit it like any other text file to cover your tracks. Unfortunately, while you were hiding your tracks from the auditors, you ended up losing a whole bunch of files. Now you need to find them. One way to do that is using the locate database. Another way is using the find command. And lastly, if you're desperate, you can grep -R for a string, and -R will look through recursively in whatever directory you happen to be in. I say desperate, but in reality you're going to use it all the time. First up is locate. Locate is actually a two-part system. There's a files database that you update with updatetb, and then you can query the files database with locate. And it just simply dumps every file or directory that it finds that matches the string that you're looking for. This is totally the preferred method to find a file, but if you're not root, you can't update the database. So the next way to approach it is to use find. And I'm just doing a really simple search here. Find and then a dot searches the current directory, and then I'm grepping out for files that match what I'm interested in. But I still haven't found that entry that I'm looking for. I've forgotten where you define eth0. So in etc. I did a grep-r eth0 and an asterisk. It recursively searches all of etc. for that particular string that you're looking for. And then I'm like, now I remember, it's in network interfaces. And I found it using grep. I would not normally have been able to find that with just the other file search commands. Find also takes perimeters, and it's definitely something you should invest some time in learning. In this case, I'm just looking for files with the name that end in .conf. That's easy. You can also search for files that were modified in the last 3 days, or files that are above a certain size or have certain permissions. With a little bit of scripting or some ingenuity, you can really use find to great advantage. Sometimes you run some sort of batch processing program, and it's going to take like 15 hours. And you know that for the 15 hours that it's running, it's burning 100% of the CPU, and your internet site isn't loading, and MySQL is complaining the whole time. And what you need is a way to set the priority on that process. There's 2 commands that let you do that. One is nice, the other is renice. Both of them use a numeric identifier to determine the priority level of the process that you're trying to run. The priority levels are relative to 0. If something has a lower priority than 0, it's going to run with more CPU time, more I/O time. So that way you can kind of establish a hierarchy of programs that you want to have CPU time available. This one is kind of tough to demonstrate working, but just syntactically, you run the nice command and then give it a nice level, in this case 20, which is going to give it really low priority. It shouldn't bog down the system at all to run this cat command. Most times though, when you run the command, you're not going to know that it needs a lot of resources. So one of the good things that you will want to be able to do is renice, and renice can take a user or it can take a process ID. In my completely fictitious server, I want my Apache processes to have the highest priority on the system so that they can serve up my important web pages quickly. So I give the www data user -10, and I don't want MySQL to bog down my machine. In reality, you would probably never do this, but I'm going to renice MySQL to, in this case, 19 and not 20, so that it has the lowest priority on the system. And remember, this is relative, so if you have 2 processes with priority 19, they share the same priority level, but everything else at 0 or better will get more processor time. Next up, a quick example or 2 of how for loops work in Bash. For those of you with no programming experience, the point of a for loop is to let you run a command multiple times, generally with some sort of variable input so that you can make 100 or 1,000 changes without having to type 100 or 1,000 commands. In this case, I'm going to do something really simple. I want to generate 100 files with a dynamic file name. So the for II is actually a variable that's set from the expansion of the 1 to 100. And then touch creates an empty file, and I've added the II to the file name so that for every value of 1 through 100, it's touching a new file with the number in it. There's no magic to II, it's just my old experience coming into play. You could call it variable, you could call it anything that you wanted, and the loop would run exactly the same. Something that'll come in handy is that Bash will automatically do file expansion when you use stars or asterisks. So you can do a for variable in file 8 asterisk, and Bash will expand that to be everything that has a file 8 in it. And then you can echo that, which means we've basically just re-implemented the ls command in a more complicated way. To actually accomplish something useful with this though, I want to remove the files that I don't like. So if I want to remove every file that has file 8 star in it, I can append an additional command at the end of the loop that does an rm for the same variable, and then all of the the 8 dots are gone. A slight twist around in what my file selection looks like, and we can echo and then delete every file in the directory. For doesn't just work on file names though, it can work on any list of anything. Effectively, it just works on arbitrary strings, and if the strings have some sort of interpretation like file names, then that's up to you to decide. In this case here, I want to feed it to domain names that I'm going to try to ping in a loop so that I don't have to type them out separately. In this loop, I want to accomplish multiple things. First, I want to do a DNS lookup on the host. I want to echo some status output, which in this case is going to say pinging, and then I want to actually ping the same host. And for this ping, I'm using a specialized version of ping with a -C, which sets the count to 1. And then it goes through, it does its DNS lookup, it does its pings, and everything looks okay. Further exploring this a little bit, I want to take the output from a command and use it as the input for a loop. So you can do that simply using the backticks operator that we explored before. In this case, I just cat etc password, and I want to use the text blocks, which are separated by either spaces or new lines, and have that as the input into the echo command in a loop. And then, based off of that, I want to get a list of the users in the password file. To do that, I can pass each individual line to a command called cut. Cut takes a delimiter and a field number. So my delimiter is a colon because that's what the password file uses, and my field delimiter or my field number is 1 because that's where the username should be at. Adding another layer to the onion, I want to find out what every user's groups are. So if I add the groups command in there and add some backticks, it's going through the password file and dynamically showing me the groups for every user. Similar in concept to for loops, and another control structure in Bash is the if statement. We'll walk through the process of building an if statement that determines some sort of information that we're interested in, namely whether a line that we're reading has the word root in it or not. grep-c here is going to help us out because that returns a count and not the text itself. I think this is pretty self-explanatory, so just watch. There's also a shorthand version that you can use. It's not really exactly the same as an if statement, but it's a little bit easier if you want something really simple. So we want to check for the existence of root and etc password again. In this case, if it does exist, it uses the and if it doesn't exist, it uses the or. The mechanism that lets this work is something called return codes. Every Unix program has a return code when it exits. If everything seems to run correctly, then the program exits with a 0, and if something happened, it exits with something that's not 0. In this case, when grep finds the string that you're looking for, it exits with a 0, and then bash knows to run the and portion of the command, which is after the 2 ampersands. If grep exits with something other than 0, like a 1 because it didn't find your string, then it uses the or. When bash fires up, it reads a variable called the path. The path specifies what directories on the system it's going to try to execute commands from. So when you run ls, which is a command, bash looks through the path in order to try to find an instance of a program called ls and then executes it for you. To get us started on this, let's check out the default path, which, since it's a variable, you can use echo $path in all uppercase. Use a local sbin, use a local bin, user whatever. When you do a which, it tells you which version of the ls command is going to be executed by bash if you were to run the command right now. So what I'm going to do is save the path to an existing variable so I can return to it later, and then use unset to remove it. Since which searches through the path, when we run it on ls with no path set, bash can't find it. So what we now have to do is reconfigure path so that it has ls in it. The easiest way for me to do that right now is to just set path back to oops, which is a variable that I created. That oops variable will maintain its value through the duration of this bash session, but it won't stay between bash sessions. Now that I've reset it, ls is present in my path again and I can run it. One other thing that you sometimes might want to do is create your own set of programs, and often you'll create a home student bin or whatever you may want it to be, and then write little one-time use scripts in there, and you want to be able to execute those without having to go into the directory or give it the full path name. So to do that, you make a directory and make some sort of shell script, whatever you want it to do. Make sure that it's executable, and then when you run it, you see that command isn't found. It's because home student mybin isn't in your path. When you run it directly, it executes as you'd expect it to. So the trick to that is you can do path equals $path, which then expands the value of the path variable into itself, and add in the bin file that you're looking, or the bin directory that you're looking to add on to. And as I mentioned, those variables only are maintained during the one bash login that you have running right now. So if you want to make it permanent, we're going to use a file called bashrc that's executed whenever you log in and fire bash up. And at the end of it, we're just going to append the value of path, which has already been set by the operating system when you log in, to add in the new bin directory that you made for yourself. Now, the next time that you log in and bash starts from an SSH cell or from a virtual console, you're going to get the new path variable. Sorry, I'm from the South and sometimes I lose syllables. Another thing that's going on here is that root has its own path because it has two things going on really. First, you want a specialized path for root because you don't want to include potentially hazardous binaries. And secondly, it adds in some additional things like user sbin that a typical user probably doesn't need. One day when you're bored to tears in your server room at 4 a.m. because something's broken, you're going to want to take a break and all you're going to have is a console. So one good thing to keep in mind is that there are a couple of console web browsers. W3M links are the big ones, and then wget and curl let you download files. First, let's take a look at W3M, which is probably already installed by default. It does most of the things that you would expect the browser to do, except display images. It also doesn't typically do JavaScript. Up and down scroll, and it shows text. It's pretty effective as a web browser. Hit Q to quit. Links, on the other hand, is a lot simpler, and it's also apparently not installed by default on Ubuntu server. It's probably fine. You're only ever going to need one command line browser, I suspect. W3M will do anything that you want it to do, but if you hit an older server, Links is probably the only thing that's going to be available. Install it and check it out. It works basically the same way. You feed it a URL, and it opens up a nice web page that you can scroll through with no graphics. What do you really need graphics for anyway? The only thing that you're missing are kitty memes. Sometimes, though, firing up an entire web browser, even if it has links with no images, is kind of a hassle. So there's a program called wget that's frequently used to download an individual file. As long as you know the complete URL, if you copy and paste it in, then wget will pull it directly on the server for you without having to transfer it and without having to fire up the big web browser like Links. I'd like to take this moment to thank Debian for letting me abuse their bandwidth for a couple of seconds while I demonstrate the command. There's one other one that you may find interesting. If you ever want to download the HTML source of a page, you can use curl, which is probably also not installed by default. But what curl does is hit the site that you've asked it to, and it'll download the HTML and the JavaScript or whatever is on the page itself without displaying it. So you can save it to a file. In this case, that's kind of what it looks like when you try to curl a giant binary file. You can also curl a website, and it dumps the HTML to std out, or you could save it to a file if you wanted to. Something else you're going to frequently have to do is compare files. It could be that someone uploads two files to the server and they need to figure out which one is the correct one. Or maybe you have two config files, like you have a backup Samba config and a current Samba config. You want to know which one has a directive that you put in. You can use WC or diff for that, or you can use MD5sum to compare binary files and determine if they're different without having to inspect the files line by line. Let's get a couple of copies of the password file to work with. And then in the second one, I'm going to actually make some changes by specifically removing the two lines at the end, and then see if we can detect the difference with some of the commands from before. We can see that they're different sizes, so that's a good hint, but we don't really know how they differ, only that they are different. So WC in the first column gives you the number of lines in the file, so we immediately see that the password.new file has two fewer lines than the original password file has. Another option is that if we know two files could be this different, but we don't know for sure, we can use MD5sum, which generates a checksum of two files. And the checksum, in theory, should be guaranteed to be unique between the files. So if the checksums come up the same, like here for password and password.same, then you know by definition they're the same file, including the same content. If we want to see the actual text difference between password and password.new, the diff command is the first place to look. There's two primarily used formats. The first is kind of the line by line, and then diff with a lowercase y is a side-by-side view. And you can see here that there are two lines in the first file that didn't exist in the second file, as indicated by the less than symbols in the middle of the screen. Now, just something that I think might be interesting and will probably catch you at some point. When you compress files, they're not guaranteed to compress the same way every time. So if we gzip the password file and a copy of the password file, the MD5 sums actually come out differently. Even though they'll decompress to the same text, they're not technically the same file. This is kind of weird because you would expect that to be the case, but it typically isn't. This could eventually matter to you because it means that you can't compress two tar backups of the same files and expect them to get the same compressed checksum. At this point in the video, I fully expect that you're sick of entering your password. There is a way that you can get around entering your password for sudo. I don't know that I advise it, but I do it myself. And I felt that it's only fair to tell you and give you the option to set it up so that you don't have to enter your password to sudo root either. First, let's remind ourselves of what group the student user is in. There's one group that really matters, the admin group here, which you may or may not expect to be valid. If you check out the sudoers file, you can see that the admin group has access to become root. That's not really good enough for our purposes, so we're going to create a new group called awesome. And awesome can sudo root, or anything really, can do anything with sudo without entering in a password. So what we have to do is create an awesome group, add student to the awesome group, and then try sudo without a password and see if it works. Also here, sudo-k forces sudo to clear any cached credentials that it has for your user. If we didn't do that, we obviously wouldn't have a valid test of whether or not we can get to root without a password. Sometimes also you'll want a particular user to be able to run something as root, but not be able to run everything as root. So sudo gives you kind of an option to do this. I'm going to restrict the awesome group to only be able to run bin cat with no password instead of any command with no password. If you exit-vi sudo and leave bad syntax in the sudoers file, it'll give you an option to re-edit it, just as a tip. Save it out and do a sudo-k as student again to clear our credentials. When we try to sudo su as normal, we get a password request. So let's exit sudo-k again to clear out the credentials. When we do just a regular cat on etc shadow, which is a read-only by root file, it's going to get rejected. But when we do sudo cat etc shadow, then it lets us do it without a password. Luckily, there's no demonstrations for these last two, which means that you've survived the gauntlet of my bad telestration skills. But number two here, occasionally when you boot your machine, especially if there's been a power outage or something like that, you're going to get a screen that comes up, possibly with a progress meter, that's called an FSCK, and it's going to look kind of grumpy. It's going to look like your machine is revolting and that it's slowly deleting all of your files. It's actually just fine. It's doing a file system check because the file system wasn't unmounted cleanly. The problem is when you're first starting out, this is an incredibly scary screen because you rapidly imagine that your hard drive is being eaten up by Linux somehow, that you've done something wrong and it's just systematically going through and destroying all of your files. Normally that's not the case, although I won't say that it isn't always the case. It's much less frequent than it used to be, but in the old days, sometimes an FS check could be a scary thing. Don't worry about it now. Extended 4, XFS, almost all of the modern journaled file systems are immune to these kind of random deletions during a file system check. In fact, they're almost always even fast. The worst that can be said about a file system check normally is that it always happens on the reboot that you need it to happen the fastest. So like when your mail server goes down right in the middle of the daytime and you have to have it back up by lunch. The next to last tip that I can offer is probably one that I might catch some crap for, but it's basically don't use the GUI if you can help it. Linux has really nice GUIs. There's a lot of different window managers that are awesome. KDE and GNOME come to mind, but there are literally dozens of them. And those are fine to use. You know, I don't have any problem with using a graphical interface to get your job done. What I do kind of have a problem with is using the GUI to configure software. You're never going to quite get the learning that you need in order to fully understand what's going on under the hood. You can configure Apache with the graphical interface if you can find one that you like, but I wouldn't do it. For the first problem is if you don't have that graphical interface on the next computer that you go to, you're still not going to understand how to configure Apache. So a lot of times GUIs are built as crutches for people who are just starting out. Really avoid using them for that. Later on, maybe an LDAP browser, for instance, makes a really great program that it's fine to use a GUI with, because LDAP is kind of nasty to do without it. But if you're configuring Apache or setting up an FTP server or doing MySQL stuff, try to avoid it at first. And then once you really understand what's going on under the hood, feel free to switch if you like it. But when you're using SSH from Asia on business travel and you have to fix your server somewhere in California, your GUI just simply is probably not going to work. You're not going to have the throughput, and it's going to be way too late to pull it off. And part of what this is about, I know, is your first server, but it's also about starting a career and doing things the right way. And my belief is that the right way to do Linux administration is to learn how to work with config files and how to do everything on the console. And even when I am at work, my machine, which has 3 monitors or whatever, will have, an AIM client and an IRC client and some email, and then it'll have 15, 20, or 30 terminals open. I still do all of my configuration through the terminal, even though GUI tools are getting better and better with every new generation of the software. But they're not for me. And kind of as the final parting shot, when you get hired as a Linux administrator, it's pretty much expected that you can use the command line. And more importantly, when your boss comes to look over your shoulder and see what's going on, it looks a lot more impressive if you're going through and you're piping the password file to set and then doing some sort of loop transform on it in order to get a list of the users that haven't expired yet. And so we've reached the end. The last bit of my sage wisdom that I can impart is that Linux, or GNU Linux, is not like other operating systems that you've used. The other operating systems that you've used have been designed to hide things that are difficult from you. They're designed so that you can click some checkboxes and hit some drop-down menus and get a mail server up and working in a couple of hours. Linux does not do that. The philosophy is very much opposed to that. If it's difficult to work, then it's probably powerful. The flip side of that is, if it's powerful, it's probably more difficult to work with. It doesn't mean that it's hard. So it's kind of an issue of learning curves. The Linux learning curve is steeper, but you finally reach this point in the curve where you can basically know everything about it simply by taking what you already know and expanding it just a little bit. Whereas other operating systems designed their learning curves to be less steep, but you never reach that level of fully understanding what's going on. Every piece of software has its own quirks, and everything that you try to do has kind of a constant difficulty. Your new Linux server that hopefully is working really great for you now is not going to hold your hand. If you want to wipe the hard drive with a single command, it's going to let you do it. No difficulty whatsoever. But at the same time, it's not going to get in your way when you want to do something that's kind of out of the norm. If you want to route email in a special way, something that no one else on the internet does, it's not going to stand in your way if you want to pull it off. The rewards here are great, though. If in some point in the future you want to replace your router, once you've been working with Linux for a while, you're going to think, oh, I install a Linux box, it's going to take me about 6 commands to replace my NAT router, to get DHCP up and running, to do all the things that we've talked about, plus so much more. It can be a firewall, it can be a dynamic router with BGP and OSPF, it can do email. All of these things are possible, and they're all free. People do this partially out of the good of their heart, partially out of some sort of, not really an arrogance, but there's a currency in open source software, and the currency is fed by getting code committed and by being recognized for your achievements, and not so much for being paid for software licenses. And so maybe that's my final and even most valuable advice in this whole thing. If you find yourself really liking something, if you find out that you really, really, really love routing in Linux, and that it's dynamic, but there's something that you're missing, search it out. There's 100 or 1,000 people out there who really, really love it and more than you do. And they're going to have answers for you. If they don't have answers, they'll find them. They're very generally supportive, and these are the kind of things that you can find a niche that really excites you. And Linux, unlike those other operating systems, doesn't get in your way at all. You can make it do pretty much whatever you want. So go out and do it. Have fun. And thank you for listening. I sincerely hope from the bottom of my heart that this was worth your time and that it was worth mine to do it. And I also sincerely thank my friends and family who have listened to hours, if not months, of me droning on and on about topics and who should listen to this and who might find it valuable. Since late 2008, when this first popped into my head, I've gone through 4 revisions, and I really have had a blast with it, and I hope that you found it useful.